The Ocean's Whisper, a journey into the last wild frontier. Nothing quite captures the imagination like the vast, mysterious expanse of our oceans. Covering over 70% of our planet, these blue depths remain Earth's final unexplored wilderness. While humans have mapped the moon's surface with remarkable precision, we've charted less than 20% of our ocean floors. Today, we're diving into this enigmatic world, exploring not just what we know, but the profound mysteries that still elude our understanding. The ocean story begins with staggering numbers. 5 major oceans span our globe, containing roughly 97% of Earth's water. The Pacific alone covers more area than all land masses combined. But these statistics barely scratch the surface of what makes our oceans truly remarkable. They're ancient beyond comprehension, forming over 3.8 billion years ago, making them the cradle of all life on our planet. When we think of ocean exploration, we often picture modern submarines and high-tech diving equipment. But humanity's relationship with the sea stretches back millennia. Ancient Polynesians navigated vast Pacific distances using only the stars, currents, and wildlife patterns. The Phoenicians established maritime trade routes throughout the Mediterranean as early as 1500 BCE. These early explorers understood something fundamental. The ocean isn't just a barrier between lands. It's a highway connecting civilizations. The modern era of oceanography began in the mid-19th century with the HMS Challenger expedition. From 1872 to 1876, this converted Royal Navy vessel circumnavigated the globe, collecting data that would form the foundation of oceanography as a science. The expedition discovered over 4,700 new marine species and made the first systematic measurements of ocean temperatures, currents, and depths. This landmark journey revealed how little we understood about the underwater world and sparked scientific curiosity that continues today. Perhaps the most profound ocean discovery came in the 1970s with the identification of hydrothermal vents. These underwater geysers spew superheated, mineral-rich water into the frigid deep sea, creating environments that completely upended our understanding of life itself. Around these vents, scientists discovered thriving ecosystems powered not by sunlight through photosynthesis, but by chemosynthesis, microbes converting chemicals from the vents into energy. This revolutionary finding suggested life could exist in environments previously thought impossible, with profound implications for our search for extraterrestrial life. The ocean's influence extends far beyond its shores. It's our planet's primary climate regulator, absorbing over 90% of the heat generated by greenhouse gases and capturing roughly 30% of carbon dioxide emissions. Ocean currents distribute this heat globally, with the Gulf Stream alone delivering warmth equivalent to 1 million power plants to Northern Europe. Without this oceanic conveyor belt, London would experience temperatures similar to those in much colder regions like Labrador, Canada. But this climate regulation comes at a cost. Our oceans are changing at an unprecedented rate. Since the Industrial Revolution, they've absorbed approximately 525 billion tons of CO2, increasing acidity by 30%. This acidification threatens marine organisms that build calcium carbonate shells or skeletons, including corals, mollusks, and certain plankton species that form the foundation of marine food webs. It's like slowly dissolving the bones of the ocean. The warming of our oceans presents another critical challenge. Marine heat waves have doubled in frequency since 1982, devastating ecosystems worldwide. The Great Barrier Reef has experienced 5 mass bleaching events since 1998, with the 2016-2017 event killing approximately 50% of its corals. These aren't just ecological tragedies. They represent the loss of biodiversity hotspots that support fisheries, tourism, and coastal protection worth billions annually. Yet despite these challenges, our oceans continue to reveal astonishing resilience and adaptation. Take the story of Shark Bay in Western Australia. In 2011, a marine heat wave devastated its seagrass meadows, which had been stable for over 4,000 years. Scientists feared permanent ecosystem collapse. Instead, they witnessed something remarkable: genetic adaptation. The surviving seagrasses weren't just lucky. They possessed genetic variations that allowed them to withstand higher temperatures. Nature had built-in resilience that no one anticipated. The deep sea remains Earth's least explored environment. The average ocean depth exceeds 3,800 meters, with the Mariana Trench plunging to nearly 11,000 meters, deeper than Mount Everest is tall. These abyssal regions experience pressures exceeding 1,000 atmospheres, complete darkness, and near-freezing temperatures. Yet life thrives even here, adapted in ways that continue to astonish scientists. Consider the recent discovery of the Casper octopus in 2016, found at depths of 4,000 meters. Unlike any known octopus, this ghost-like creature lacks pigmentation and muscle tone typical of its relatives. Even more surprising was its reproductive strategy. Females were observed guarding their eggs for years in the frigid deep, the longest brooding period of any known animal. Each deep-sea expedition reveals species and behaviors that rewrite our understanding of life's possibilities. The ocean's mysteries extend beyond biology to geology. The mid-ocean ridges form the longest mountain range on Earth, stretching over 65,000 kilometers. These underwater mountains are where new seafloor is constantly created as tectonic plates spread apart. This process, called seafloor spreading, means the entire ocean floor is recycled approximately every 200 million years, relatively young in geological terms. The oldest oceanic crust is only about 180 million years old, while some continental rocks date back 4 billion years. Our exploration of these underwater mountain ranges led to one of the most significant scientific breakthroughs of the 20th century, the confirmation of plate tectonics. The discovery that Earth's crust is divided into massive plates that move and interact revolutionized our understanding of earthquakes, volcanoes, and the very formation of continents. This theory, now fundamental to geology, was largely confirmed through ocean exploration in the 1950s and 1960s. The ocean's influence on human culture is equally profound. Maritime traditions have shaped civilizations from the Vikings to the Polynesians. The sea features prominently in mythology worldwide, from Poseidon's realm in Greek legends to the Kraken of Norse tales and Tangaroa in Maori tradition. These stories reflect both our fascination with and fear of the ocean's power and mystery. This cultural significance continues today. The blue economy, sustainable use of ocean resources for economic growth, is valued at approximately $2.5 trillion annually, making it the world's seventh largest economy if ranked alongside countries. From shipping and fisheries to tourism and emerging industries like marine biotechnology, the ocean remains central to human prosperity. Yet our relationship with the ocean is increasingly complex. Overfishing threatens 33% of global fish stocks, while plastic pollution has reached even the deepest ocean trenches. A 2019 expedition to the Mariana Trench discovered a plastic bag at 10,898 meters, a sobering reminder that human impact reaches the planet's most remote environments. The statistics are staggering. Each year, approximately 8 million metric tons of plastic enter our oceans, equivalent to dumping a garbage truck of plastic into the sea every minute. By 2050, some projections suggest there could be more plastic than fish in the ocean by weight. This pollution isn't just unsightly, it's deadly. Marine species from seabirds to whales mistake plastic for food, while microplastics, particles smaller than 5 millimeters, have infiltrated marine food webs from plankton to predators. Climate change compounds these challenges. Rising sea levels threaten coastal communities worldwide, with projections suggesting a rise of 0.3 to 1.2 meters by 2100, depending on emission scenarios. For low-lying island nations, like the Maldives, where 80% of the land is less than 1 meter above sea level, this isn't an abstract future threat, but an existential crisis. Yet amid these challenges, there are reasons for hope. Marine protected areas now cover approximately 8% of the world's oceans, up from less than 1% in 2000. While still short of international targets, this represents significant progress. These protected zones have demonstrated remarkable recovery potential. In Palau's marine sanctuary, fish biomass increased by 449% within 2 years of protection. In New Zealand's Goat Island Marine Reserve, snapper density is 40 times higher inside the reserve than in surrounding waters. Technological innovations are revolutionizing ocean conservation. Satellite monitoring now tracks illegal fishing vessels across the globe, DNA analysis of seawater samples, known as environmental DNA or eDNA, can detect species presence without direct observation, transforming biodiversity monitoring. Artificial intelligence is being deployed to analyze underwater imagery, identifying coral health and fish populations with unprecedented efficiency. Perhaps most encouraging is the growing global recognition of the ocean's importance. The United Nations declared 2021-2030 the Decade of Ocean Science for Sustainable Development, coordinating international efforts to reverse ocean decline. Major corporations are committing to plastic reduction and sustainable seafood sourcing. Grassroots movements from beach cleanups to sustainable seafood guides are engaging citizens worldwide. The ocean's future remains uncertain, balanced between growing threats and expanding protection efforts. What is certain is that our fate is inextricably linked with the blue world that covers most of our planet. As oceanographer Sylvia Earle reminds us, no water, no life. No blue, no green. Our journey into ocean exploration continues to accelerate. In 2019, the 5 Deeps expedition completed the first manned descents to the deepest points in all 5 oceans. The Necton mission is mapping the Indian Ocean's uncharted depths. The Ocean Cleanup Project is developing technologies to remove plastic from major ocean garbage patches. Each initiative adds to our understanding while addressing critical threats. As we look to the future, emerging technologies promise to transform our relationship with the ocean. Autonomous underwater vehicles can now explore for months without human intervention. Floating wind farms are harnessing the ocean's renewable energy potential. Sustainable aquaculture systems are being designed to produce protein with minimal environmental impact. Marine biotechnology is discovering compounds from ocean organisms with applications from medicine to industrial processes. The ocean remains Earth's greatest frontier, a world of extremes where life has evolved solutions to challenges we're only beginning to understand. From enzymes that function at crushing depths to organisms that thrive without oxygen, marine life offers blueprints for innovation across disciplines. Biomimicry, designing technologies inspired by nature, increasingly looks to the ocean for solutions to human challenges. Our exploration of the ocean isn't just about discovering what exists beneath the waves, it's about understanding our place within Earth's systems. The ocean connects all continents, regulates our climate, provides food for billions, and generates over half the oxygen we breathe. It's not separate from our world, it is our world. As we conclude this journey through the ocean's past, present, and possible futures, one truth becomes clear. The more we learn about our blue planet, the more we recognize how much remains unknown. Each discovery reveals new questions. Each innovation opens new possibilities. The ocean's greatest lesson may be humility, reminding us that even in our technologically advanced age, Earth still holds mysteries beyond our comprehension. The ocean whispers us across time, carrying messages from our planet's past and possibilities for its future. As we face unprecedented environmental challenges, these whispers become increasingly urgent. Will we listen? The answer may determine not just the ocean's fate, but our own.